What we're looking at in this segment is lesson number 4 in Algebra 1. And this lesson is dealing with um, the use of exponent laws to write equivalent expressions. For example, we're looking at 4.5 square that is raised to the 5th power. What we have here is a case where we would have a power that is raised to another power. And whenever a power is raised to a power, what we're going to do is we're going to multiply the exponent. So 4.5, and that would be 2 times 5, and it's going to land us 4.5 raised to the 10. Number 2 here is looking at we're looking at 3/7 raised to the -3. Anything that is raised to a negative power is actually the inverse, and the inverse of any fraction is to reciprocate it. For example, this negative sign is an indication that the rational number here will be reciprocated. So what we're looking at is 7/3, and this will be raised to the 3rd. But this 3, this power of 3, based on the laws of the quotients, we'll have 7/3/3 as an equivalent expression for this. Let's take a look at the third example. For this one, what we're looking at is basically -2 times 6, and this is raised to the 4th. What this really means is that the -2 will be raised to the 4th. The +6 will also be raised to the 4th. So because we're multiplying here, we are able to execute the idea like that. Let's take a look at number 4. So for number 4, let me quickly rewrite what we have. We're looking at -3.1, and this is raised to the 10th, and we're dividing this by -3.1, which is raised to the 3rd. Remember that whenever we're dividing and we are actually dividing the same base, we're going to keep that base, which is -3.1, and we're going to subtract the powers. For example, 10 minus 3. So as we could see here, that's 10, and this is 3. Finally, -3.1 is raised to the 7th power. So -3.1 raised to the 7th is equivalent to everything there. For number 5, we're looking at 7 raised to the -4 times 7 times 7 raised to the 3rd. Be advised that whenever we do not see a power, like in this case, the default power is to the 1, which means that we are actually multiplying the same base. So we're going to keep the base, and we're going to add the exponent. This will leave us with 7 raised to the 0. Right, so 7 to the 0 is an equivalent exponent for this expression for all of this. Now, in this case, we're not asked to represent equivalent expressions. We're asked to give the value. So we have to take key notice. There's a huge difference with finding an expression that is equivalent to another in relation to finding the value of. So let us quickly take a look at this. This is the 3rd root or we could call it the cubic root of 64. Now, in order to work this out, we could quickly represent this using rational exponent. For example, this is the same as 64 raised to the 1/3. Be advised that the cubic root is equivalent to the third exponent. Now, let us see if we could break this down further. We can represent 64 using a base of 4. For example, 4 raised to the third is 64. This is our 64 right there, right? And this is also raised to the third. Remember the context that whenever a power is raised to a power, we're going to keep the base and then we're going to multiply the powers. You're going to notice that this 3 would cancel this. What are we left with? 4 to the 1. And this is the identity exponent, which is 4. Let's go further. The square root of 64 can be written as 64 raised to the half. We're suggesting that a half power, we're suggesting that a half power is equivalent to the square root. Now, let us continue. 64 can be written as 8 raised to the second power, and that was also raised to the half. Again, this is the power of a power rule that will take precedence. What do I mean? Whenever we have a power, which is this 2, that is raised to this, which is another power, we're going to keep the base and we're going to multiply the powers. At this time, we're realizing that 2 cancel 2, we're left with 8 to the 1, which has a value of 8. Now, let's look at this question 8. Explain why the value of the square root of 64 is different from the value of the cubic root of 64. Well, we could simply say that if you see different index, because this one is 64 to the half, and this is 64 to the third. So we're saying different index, right? So if we have different index, we have different index. And different index simply implies that we have different exponent. So that will be the huge difference between the two. We have different index, which means we have different exponents. Now let's take a quick look at these, number 9, number 10. Now what we want to do is to find the value of the variable that makes the equation true. Now we could represent these ideas a number of ways. Let's take a closer look. The square root of y times the square root of y is equal to 15. Now, there are a number of ways we could do that. One of the ways we could have done that is to do this. We could have said, this means that we have the square root of y to the second. Because if you look here, this is y and this is y. So we definitely were multiplying those y's. So we'll have y squared. Technically, it is suggesting that y squared is 15. But whenever we have a square and the square root combining, they will cancel each other out because one is the inverse of the other. So y is equal to 15. But let us say I never felt like I wanted to do it that way. Another way that we could have looked at this is to simply represent this in rational exponent. For example, this is y to the half times y to the half, which is equal to 15. Y to the half times y to the half. We're going to keep the exponent and we're going to keep the base, and we're going to add the exponent. This should equal to 15. Let's take a closer look. A half plus a half will give us y to the 1. So I'm suggesting that pay keen attention to this. Half plus a half is 1. Now, 1 is the identity exponent, right? That means y is equal to 15. So that's another way that we could have done it. We would have gotten the same answer. Let's take a closer look to the last one here. Now, in this one, what we're looking at is the cubic root of g. And there was 3 of them that were multiplying. One of the ways that I could have looked at this was, so my solution 1 is, this is the third root of g times g times g, which means it's g to the third. And this is equal to -3. What I'm suggesting here is we're taking the cubic root of g cube. A cube and a cubic root, they're inverse. They cancel out each other. So g is simply -3, because the cubic root and a cube will cancel each other. What if I never felt like I wanted to do it that way? Solution 2 is to convert the radical into rational. For example, this is the same as g to the third, so would be the other one, and so will be the other one. And it is said that this is equal to -3. On my left side here, I'm noticing that I am multiplying the same base, which means I'm going to add my exponents. And this is equal to -3. Now, if I'm adding this, my final response is 3 over 3. 3 over 3 will cancel to give 1. So this is my g. This is the identity exponent. G to the 1 is g, which is equal to -3, and we're done. So there are various ways to approach these problems. All we have to do is just to take the approach, try not to make any errors. Thank you for watching Daily Maths Concepts. See you next time.